Section 12.4 and 12.5, it's all about the surface area of pyramids and cones. Make sure you get this information into your notes. Your table of contents will look something like this. And we're going to start with a quick video clip about different parts of pyramids and cones. So here we have a square pyramid, and we can kind of turn it around. You can see we've got this square pyramid. The base is this green square, so it would be square BCDF. The lateral faces, they're kind of these polka dotted triangles. So here would be triangle ACD, here would be triangle ABC, triangle AFB, and triangle ADF. So we would have 4 lateral faces. Let's see, other things. This blue segment is the apothem of the base. This is the radius of the base. This red side, this red segment is called the slant height. The yellow is the height, or the altitude. So it's important to keep those distinct. Here's the altitude, or the height, and here is the slant height. Lateral edges would be, for example, AF, AD, AC, AB. And then base edges would be things like BC, CD, DF, and BF. So there we go, parts of a pyramid. So let's recap parts of prisms. To draw yourself out a prism, for example our square prism, I'm going to draw what looks like a parallelogram, but it represents a square. Then I'm going to connect each of the vertices of the square to that apex point A. I'll kind of bold out the front corners and dot the back corners. And so here we have our square pyramid. The base is square BCDF. That blue segment is the apothem, GE, in other words, the apothem of the base. The green segment is the slant height. Slant height is segment AE. And then that purple segment, AG, is the height, or the altitude of the pyramid. And so let's say that we have a base edge length of 6 units and a slant height of 5 units. And now we want the net of that pyramid. We'll start with the square base. So we have square BCDF. Next, we've got our apothem. We can just kind of note that in the blue segment there. Then we have our slant height, which creates one of the lateral faces. So here we have triangle ADF. Likewise, we'll finish up with all the remaining lateral faces. And so to build the area formula for lateral area, note that we'll want the combined area of each of these lateral faces. So we have 4 triangles. 4 triangles where the base is 6 units. So for example, CD is 6 units. The height is represented by the slant height, the green length. So 5. So we have 4 triangles, half base times height, plus half base times height, and so on. Please notice that each of these 4 terms has a 1/2, and each of them has the same height, right? The slant height is 5 for each of those 4 triangles. And so if we do a bit of factoring, we factor out 1/2, we factor out the slant height, in other words, h of the triangles, and we see that we've got the perimeter of the base. Now, once again, remember, h in this equation refers to the height of a triangle. The height of the triangle coincides with the slant height of the pyramid. And so our formula for lateral area of a pyramid is 1/2 times the perimeter of the base times the slant height of the pyramid. So that will give us the combined area of those 4 triangles that you see highlighted in yellow. So here, our lateral area is 60 square units. Total surface area is the lateral area as well as the base area. So lateral area plus 1 base for a pyramid. And remember, lateral area is 1/2 times perimeter times slant height. So either of these two equations will work for surface area of a pyramid. And so here we have lateral area, which was given as 60. We calculated that just previously. And then the base area is that square highlighted in orange, so a 6 by 6 square. And so our total surface area is 96 square units. Next, let's take a look at surface area of cones. First, we'll describe some of the special segments of a cone. Cone, and you'll notice the base of the cone is this circle, so circle centered at K. The lateral area would refer to all of this green area. So let me change up this surface style. Let's just call it like that. So all of the kind of green area would be the lateral area. This blue segment is the slant height, so that would be ML, and KL would refer to the height or the altitude of the cone. And so to recap, parts of a cone, we have the base, which is circle K, the radius, which is segment KM, the height, or the altitude of the cone, is called segment KL, that's the red segment, and the slant height is segment LM, the blue segment. And so lateral area of a cone is related to lateral area of a pyramid. So lateral area of a pyramid, 1/2 times perimeter times slant height. Now if you think about the perimeter of the base of a cone, well, the perimeter is that circle, and so the circumference is the perimeter of the base. So circumference, 2 pi r, is the distance around that circle. And so we'll replace perimeter of the base with circumference, which we see simplifies to just pi times r times L. So pi times radius times slant height is the lateral area of a cone. Likewise, total surface area of a cone, we'll take our total surface area for pyramids, we'll substitute in, we know lateral area is pi times r times L, and then the area of one base, well, a base is a circle. Circles have an area of pi times r squared, and so the total surface area of a cone is pi rl plus pi r squared. So now let's take a look at some example problems. First, find the exact surface area of a regular hexagonal pyramid with a slant height 10 and a base edge 6. So let's sketch this out. We have a hexagonal pyramid. We know slant height is 10, and base edge is 6. So exact surface area is lateral area plus 1 base. Lateral area is 1/2 times the perimeter of the base times the slant height. And here, since the base is a regular polygon, we'll use 1/2 perimeter times apothem for the area of one base. Now we know the perimeter of the base. Since the base edge is 6 and there are 6 of them, perimeter is 36. Slant height, that was given, 10 units. What we're missing, though, is the apothem. And so if you just consider the base, we have a regular hexagon. We know side length is 6. And so that means half of a side length is 3. And half of a central angle is 30. So therefore our apothem is 3√3. So now we're good to go. We have all of the information we need for our formula. So total surface area is 180 plus 54 root 3. And since the formula asked us for an exact surface area, we're done. 180 plus 54 square roots of 3 units squared. This next example asks for lateral area of a regular triangular pyramid. We know the base edge is 12 and the lateral edge is 10. Now remember, lateral edge is not the same as slant height. In order to use this lateral area formula, we need the slant height, which is the red segment. We'll find that using one lateral face and the Pythagorean theorem. We know the base edge is 12 and the lateral edges are both 10. Since the lateral face is an isosceles triangle, if we drop down in altitude, I know that that 12 feet segment is split in half, 6 and 6. And so the slant height can be found using the Pythagorean theorem. And so now we have all the information we need. We'll just substitute numbers in. We have 1/2 times the perimeter of the base times the slant height. So lateral area is 144 square feet. Next example, please find the approximate total surface area of a regular pentagonal pyramid given an altitude of 4 and a slant height of 5. So first let's picture this. We have our pentagonal pyramid. The height, or the altitude, is 4 inches. The slant height is 5 inches. And we need to find the approximate total surface area. So first off, take a look at the triangle drawn in with the red, green, and blue sides. The red segment represents the apothem. So apothem, height, and slant height will make a right triangle for us. Now we want total surface area. So that's lateral area plus the area of one of the bases. So 1/2 times perimeter times slant height plus the area of a pentagon, 1/2 times perimeter times apothem. We can find the apothem using the Pythagorean theorem. That's 3. However, in order to find the perimeter of the base, we'll need another triangle. So take a look at the purple segments drawn in. The purple segments use the apothem, the one that we just calculated, to help us find half of a side length. So let's take a look at one base. We know the apothem is 3, and so to find the perimeter of the base, we'll use trigonometry. First, we know one central angle is 72, and so half of a central angle is 36 degrees. And so we can find half of a side length using the tangent function. So half of a side is 2.1796. If you double that, you get one full side length. Multiply that by 5, you'll get a perimeter of 21.796. And so now we have the information we need for the area formula. We know the apothem, that's 3. The perimeter, we just calculated in purple there. And the slant height is given. That's the segment we shown in blue. So total surface area should be about 87.2 square inches. Next example, a cone has an altitude of 8 inches and a diameter of 3. Find the approximate lateral area. So let's picture this first. We have a cone. We know the altitude is 8. Take care, not the slant height, but the altitude is 8. And the diameter is 3 inches, which means the radius is half as big. So radius and altitude plus slant height form a right triangle. And so we can find the approximate slant height using the Pythagorean theorem. Approximate lateral area, pi times r times L. Stick all that into your calculator and you get about 38.4 square inches. Here we have the surface area of a cone is 39 pi square units. If the slant height is 10, what is the length of the radius? So this one we're going to use the surface area of a cone formula, but we're going to use it kind of backwards. Here's this total surface area of a cone, and we know the total length, the total surface area. We know the slant height, and we need to solve for the radius. So we can substitute in the values we know, and we'll solve for the unknown. So 39 pi equals pi times r times 10 plus pi times r squared. Now notice that each term has a pi in it. And so if I factor out a pi from the right side of the equation, I can divide both sides of the equation by pi, which simplifies to 39 equals r squared plus 10r. Now subtracting 39 gives me a factorable trinomial, looking for factors of negative 39 which sum to 10. And so that means r could be negative 13 units or 3 units. Well, since we're dealing with a geometric shape, we can't have a negative radius. So our radius here is 3 units long. And the final example. We want the total surface area of this thing. So total surface area. First of all, let's break this up into pieces. We have the roof, which is lateral area of the pyramid. We have the 4 walls, which is the lateral area of a prism. And then we have the bottom, the floor, which is just one base. So again, it's made up of lateral areas, and only one base is actually shown on the surface. So lateral area of the pyramid, 1/2 times the perimeter of the base times the slant height. Lateral area of a prism, perimeter times height, and plus that 1 square base, side length squared. Now, these individual pieces, we know a bunch of them. We know the perimeter of the base will be 40. Since it's a square, each side length is 10. We know the height of the prism is 14. We know side length, in other words, the side of one of the bases is 10. But what we don't have is slant height. So slant height is represented by that purple segment I just drew in. And so we'll need to find slant height using one of the lateral faces of the pyramid. So let's take a closer look. For that lateral face, we know lateral edges are each 13 units. Then, because the base edge is 10 units, I know that the base of 10 is split up into 2 equal parts by the slant height. And so the good old Pythagorean theorem says 5 squared plus slant height squared is 13 squared. So now we have our slant height of 12. And now we're good to go. We have all of the area formulas. So we should get 240 plus 560 plus 100 makes 900 square units of fun.